So today we're going to start graphing rational functions. We're going to start with the most basic rational functions so that you can get a feel for what's supposed to happen without the complications that they can create. Right? So our topic is graphing rational functions today with a horizontal asymptote, HA, y equals 0. They're the easiest ones to do most usually. Okay, so your objective, I will be successful when I can identify and graph the horizontal and vertical asymptotes. I can graph critical points like the x and y intercept. I can graph additional points, and I can sketch a reasonable graph of the function. Also, we'll look at end behaviors, intervals of increase and decrease, and all of that, so that you're training for the test and the things you'll be required to do in relation to a rational function. So let's talk about what is a rational function. Okay, rational function comes in the form f of x is equal to polynomial, so capital P of x, please make that a capital P. It's a polynomial numerator over q of x, which is just another polynomial. So P of x over Q of x. The rule is here that there has to be an x in the denominator. To make it a rational function, there has to be an x in the denominator. Okay? Just remember what rational means. The base word for rational is ratio, and a ratio is a fraction. Okay, so it's a fraction equation with an x in the denominator. And when you have x's in the denominators, you have restrictions. And if you have restrictions, you can't graph in that area. Okay, so let's talk about what we call those areas that we're not allowed to graph. The asymptotes, with a P in it, asymptotes. You have vertical asymptotes, horizontal, and diagonal asymptotes. These are lines that the graph can approach, but they are restrictions, which means 99% of the time, you're not allowed to cross them. Every once in a while, you will cross a horizontal asymptote. That's not going to happen this year. Okay, so you can just file that back in your head and remember that your math analysis teacher told you that every once in a while you can cross a horizontal asymptote. But we're not going to do that this year. Okay, so asymptotes are lines that you're not allowed to cross. They are restrictions. So let's go through the steps that are going to help us to answer this crazy function. The steps are this. So we're graphing a rational function, and be ready with your colors. So I'm going to do my first step in fuchsia. Okay, so the instructions for step 1, which you don't always have to do because step 1 isn't always needed, is to factor the numerator, the P of x, and the denominator, the Q of x, completely. At one point, we will be doing that. And we do it to simplify the fraction, to make a graph that's a little bit easier to manage. Okay, so we factor completely to help us simplify the fraction if possible. It also helps us to find our domain restrictions, which leads us into step 2. So let me see, I think I made an extra little note here. Right here, I'm going to write this. This helps find holes in our graph. We won't be graphing any graphs that have holes today. We'll probably do that on Monday. But this step helps us to simplify the graph, and when we simplify the graph, we create a hole in the graph. All right? So that's done with, we're done with that step. Step 2 is to find your domain restriction or restrictions. And this will become your vertical asymptote. or they will become your vertical asymptotes, plural. It's possible to have 2 or 3 or 4. Usually we won't do more than 2. Every once in a while we might do 3. Okay, so that's step 2. Step 3, identify the degrees of your numerator and your denominator to help determine the range restrictions. It will become singular. It will become your horizontal asymptote. Typically, there's only one of those if it's a function, typically. Okay? All right. So today's focus, TF, today's focus, I'll give you time to write that down. I'm out of space. If the degree of your numerator is less than the degree of your denominator, the horizontal asymptote will always be y equals 0. We will restrict y equals 0 from the graph. And it's a line, it's a horizontal line crossing where y equals 0. So basically that means your x-axis is a denied line. You're not allowed to cross it. So today's focus will be that. Tomorrow's focus will be this one. If the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is y equals lowercase p over lowercase q. And I will explain that in detail more tomorrow. Okay, so it shifts the range. We're going to use the quotient of the lead, and I'm going to all caps, the lead, not lead, but lead coefficients. So we'll talk about what that means tomorrow. And then, if the degree of your numerator is greater than the degree of the denominator, there is no horizontal asymptote. That means that we'll have a slant asymptote or a diagonal asymptote. We won't learn those this year. Okay? They only barely do them a little bit in pre-calc. All right. Then the next step, we're now on to finding critical points. And the most crucial ones are typically your x and y intercepts. If you have them, you graph them because it's easy to find at the 0. It's easy to find where x equals 0 and where y equals 0 because all you're doing is plugging zeros into the equation. So we're going to graph them. If you wanted to just put yourself a little note, your x-intercept is when your y equals 0. It's whatever x is when your y equals 0. And then your y-intercept would be 0 on your x, and then whatever your y is. That's your y-intercept. So you're plugging in zeros to find your x and y-intercept. Switching to my burnt orange color here. You're going to pick points for x that are just beyond your vertical asymptotes. This is just going to help us draw a reasonable graph. We plug them into the function to find their corresponding y's, and we graph them. And then step 6, we're going to connect all our graphed points with smooth curves approaching the asymptotes. Okay, and then we'll identify all our other critical information that you will be asked to identify on the test. So we will also look for end behaviors and intervals of increase and decrease. There won't be intervals of constants, but there will be intervals of increase and decrease because it's all curves. Curves. The lines are always curving all of the time. It's never flat. Okay, so end behaviors and intervals of increase and decrease. All right, so I'm getting ready to pick up my pink pencil to do step 1. So I'm color coding as I go. All right, so we are going to graph this function y equals 2 over x plus 2. What makes it rational? X in the denominator. So it's a rational function. Okay, so it's not linear, even though it's x to the first power. It's rational, so it'll have curves. So step 1 is to factor completely. So, oops, I don't want that. Go away. So, can I factor my numerator? What am I going to factor out of 2? Nothing. Can I factor my denominator? Have anything in common? No. So in this case, it's not needed. Okay, when it's not needed, that means there are no holes. Well, actually, if it's not needed, then we can't simplify it. And if we can't simplify it, then there's no holes. So it's not needed. Step 2 is to find your domain restrictions. So we look to what when we're talking about a fraction? For wanting to deny or restrict something, we look at the denominator. And we say x plus 2 is not allowed to equal 0 because that's a restriction. Right? So you would solve that. X plus 2, what x would make that equal 0? X cannot equal -2. Therefore, my vertical asymptote is my restriction. We are going to graph in a dashed line to say that it is not part of our graph. We can approach it, but we cannot use it. We are denying it. So dashed line to indicate that this is not part of the graph. If it was a solid line, then it would be part of the graph. So a dashed line labeled vertical asymptote x equals -2 is a restriction. We are not allowed to touch that line with our graph. We can approach it on the left. We can approach it on the right. We can't use it because it creates an illegal action in our graph. Okay, so let's talk about what our domain is, because as we're going along, we're identifying the critical information, and we'll write this in interval notation. So my domain comes from -infinity until I get to -2, non-inclusive, because -2 I can approach but not include. Union with -2 to infinity, but denying -2 as part of the graph. But I can pick all the other x's in the world that I want. Just can't pick x equals -2. Okay, so now I'm switching to step 3 to find my range restriction. And I think this is going to be the new information. So far, I don't think any of that is new information. I don't have to teach you to do that. You already know. Okay, so now we're going to look at our horizontal asymptote. So I'm going to do the degree of the numerator, because that's what it tells us to do. Look at the degrees of your numerator and denominator. So I picked up my red pen, and I'm going to add a little bit to my equation. So in my numerator, I'm looking at the degree of my numerator. Well, you look at the degrees on the x's. Numerator doesn't have an x, right? So what I'm going to do is I'm going to write an x in, but I'm going to raise it to the 0 power, because everything to the 0 power equals 1, right? Okay, so it still says 2. But now I know that it has a degree of 0 because there's no x up there. So it doesn't have a degree that I can use. So the numerator has a degree of 0. And looking at my denominator, on my x, the largest exponent is a 1, because that's a 1. So if you would just put those in red so that you can address them and when you're doing your homework tonight. So the degree of 0 over 1. So if I write that as a statement, that says 0 is what compared to 1? Less than, equal to, or greater than? Less than. Therefore, because of that situation, you know you have 3 bullets under the horizontal asymptote. This one is the first bullet, right? This is this one that says if the degree of p of x is less than x of x. Yes, so we went 0 is less than 1. Horizontal asymptote is y equals 0. So we're going to say, therefore, the horizontal asymptote is y equals 0. Just to be clear about what I'm doing there. So I'm going to go to where y equals 0, which is right here where the x-axis is, and I'm going to draw my horizontal asymptote. I cannot. My graph can't touch that point, can't touch that line. Let's label it horizontal asymptote, y equals 0. Always want the equation on there to identify what are you denying. Restriction. Let's write the range. So range is you're reading bottom to top. So can I graph way down here at -infinity? Am I denied -infinity? No. And as I move up, What am I approaching? 0. And then I can't graph any zeros. But after I can hop over 0, and then I can continue getting any y I want. So my range is denying 0. That's what your asymptote helps you to define. All right, moving on to the next color. So step 4 is to find your x and y intercepts. So we're looking for where does the graph cross the x-axis? And I'm going to ask you a question. Can the graph cross the x-axis, or did I deny it? I denied it. It's restricted. So I'm going to make myself a note that the x-intercept, that there is none. Because the horizontal asymptote denies. I can't graph right there. So there's no sense in me plugging in a 0 for y because I'm not going to get an answer. I'm not. But let's do the y-intercept because I don't think the y-axis is denied, right? Those points are all available for me to graph except for y equals 0. I can't do that, but I can graph all the other ones. So we do this by going y is equal to 2 over, and we're going to plug a 0 in for x, 0 over 2. So we're plugging in a 0 for x because that'll tell us our y-intercept. And we get 2 over 2, which is 1. So my y-intercept is 0 for x, 1 for y. So I'm going to come over to my graph. I'm actually going to plot that. Now I'm going to teach you to reflect it. Okay, I want to walk to the board, but I'm on video, so I can't. So how do I reflect that? I have to reflect it across my asymptotes. So this is going to graph up here, and then its partner graph is going to be across both asymptotes. So here's how I do it. I go down 1, right 2 to the intersection of my asymptotes. Did you follow that? Down 1, right 2. And then you just do it again. Down 1, right 2. And you reflect that point. I'll show you later that that's actually a true statement. But so far we've graphed 2 points. And later on, you'll get to where that's enough. But I'm not ready for that to be enough yet, because I really would like you to see how this works a little more. Be a little more precise with your graph. Okay, so that's step 4. Step 5 is to pick some points. So I'm picking up my orange pen here. I'm going to make just a little short table of values where I put the x, and then I write the equation 2 over x plus 2, and then I'm going to do some math, and I'm going to find the corresponding ones. So now we're on graphing some additional points. So what instructions did I give you for that? I'll go back. Pick points for x that are just beyond the vertical asymptotes. Okay, so could I pick -3? Yeah, I could pick -3. What else could I pick? Go on the other side, really close. -1. Now I have a feeling that these will be reflections of each other across the intersection of the asymptotes, but we're going to show the math so that you can trust it. So let's plug in a -3. So we're going to 2 over -3 plus 2. Which gives us 2 over -1. Do you agree? Yes? Which is -2. So we're going to graph this point, -3, -2. Now, I already want to just count to the intersection and reflect it. Because it's one left of the vertical asymptote, I could reflect it to the right of the vertical asymptote, and I could just take it up here. So you watch, it's going to be right here at -1, 2, because it's up 2, right 1, up 2, right 1. And that's where x is -1. Watch, it's going to happen. So 2 over -1 plus 2, which is 2 over -1 plus 2 is +1. 2 divided 1 is 2. So -1, 2. So you see a little trust there for what I'm telling you is the truth, that once you graph a point in one quadrant here, you can reflect it to its catty corner. You know what catty corner is, right? Diagonally across to the quadrant. Because your graph should be always, I'm going to point to it here, flipping. Hey, oh, I got to do it here. Sorry. So if I graph here in this section, then I would graph. I can't do it from upside down. Sorry. Okay, so if I graph up here, if my points are in this section, I won't be graphing in this section. I'll go catty corner and graph down here. Because the graph is always going to switch over the horizontal asymptote. Switches up and down over the asymptotes. Okay? All right, so now we're going to graph. So I'm going to pick up my black pen, and I'm going to connect these points, and I'm going to do it in a smooth curve. And my graph is always approaching the asymptotes. So I would go really close to my horizontal asymptote and curve down through, and then approach this other one. Always approaching your asymptotes, and then curving through the points that you graph. And you do the same thing on the other side. So on this side of your vertical asymptote, you're starting really close and then angling away, curving through your graphed points, and then approaching your asymptote again. Put arrows to indicate that that continues to happen. And it's a really steep curve and a really gentle curve on the bottom, but you're always approaching those asymptotes. Okay? So let's decide now that if we have it graphed, we have a couple things to do. What is my graph doing left to right? Because now I'm going to look at my levels of my intervals of increase and decrease. What is this graph doing? As I read it left to right, it is always decreasing. It's always falling. For a long time, it's barely falling. And then it gets a really steep curve, and then it continues to fall. Then I look to this side, reading it left to right. What is this graph always doing? Decreasing. So it's always decreasing. So I have an interval of decrease that starts at negative infinity, left to right, and approaches what line? Left to right. The horizontal asymptote, the vertical asymptote, -2. It's approaching -2, right? It's all, that graph is always decreasing left to right. Reading it after the, so hop over the asymptote. What's it always doing? Decreasing. So on the other side, so put a union, on the other side, from -2 to infinity. This graph is always decreasing, which is crazy because it goes from 0 down to negative infinity, and then it hops up to positive infinity and drops down to 0. That's kind of crazy. Let's do the end behaviors. Okay, end behaviors. So I'm asking now what's happening on this end. This is an end on the left end, and this is an end on the right. So I'm talking about what's happening. What are the behaviors of my graph? So as I go left, as x approaches negative infinity, what is my y? What is my range approaching? As I go here, what line am I approaching on my y? What's the top? 0. Y approaches 0. I can't cross it. But the closer I get to negative infinity on the x, the closer I get to 0 on the y. Let's talk about the end behaviors on the right. So as I go to this end, as x approaches positive infinity, as I go right, what's my y getting closer and closer and closer and closer and closer to? It's approaching 0. It's not going to reach it because we're not allowed to cross it. So that's all your important information. You've got your graphs. They're labeled. You found your domain and range. You found your x and y intercepts. And you have identified your intervals of increase and decrease. And you've talked about the end behaviors. A lot of information. Here we go. Problem number 2. Now this one's a little different. So I want to know if you can make a prediction. Notice that this has a negative in it, right? What do you think that's going to do to the places that I graph? The catty quarters are going to switch. So I'm going to probably graph, instead of graphing in quadrant 3 and quadrant 1, I'm going to be graphing in quadrant 2 and quadrant 4, because this graph is going to reflect vertically. Yes? Because my A, or my number out in front, is negative. So my graph is going to vertically flip. We already know this. All right, let's start with our fuchsia pen. Can I factor this? No. So not possible or not needed. I can't simplify it. There's no holes. No holes. Okay. Something that I do want to mention real quick is that when I have a negative quantity, I will usually assign that negative to the numerator. I want to make it go, but it doesn't want to go. Crap. So I will assign the negative to the numerator. That's typically what I'll do so that I can avoid the negative in my domain. All right, picking up my blue pen, I am going to find my domain restriction. So we said x minus 1 is not allowed to be 0. We can't have 0 in the denominator. So we add 1 to both sides. So x is not allowed to be positive 1, because you know you're adding 1, adding 1. Therefore, my vertical asymptote is x equals 1. So let's go deny it from our graph. It's vertical, right? Where x equals 1. So deny that from your graph. Tell your graph you're not allowed to cross this line. Label it vertical asymptote, BA, x equals 1. Practice writing your equations of those lines. Talking about your domain quickly, we're coming from negative infinity, approaching 1 from the left, hopping over 1, and approaching positive infinity. So we're only restricting x equals 1 because that would make this an illegal graph or an illegal equation. Switching to red. Okay, so remember red is your horizontal asymptote. So to find that, we look at the degrees. So again, what's the degree of your numerator? Yeah, because it's x to the 0, so it's 0. And the degree of your denominator is 1. All right. So again, when we write this left to right and we're filling that in, is it less than, greater than, or equal to? Less than. Therefore, our horizontal asymptote, when that's the case, is y equals, look at your notes, look at your steps, 0. Okay? So you have to memorize that. So let's deny y equals 0, which at this point is telling you you're denying your x-intercept, right? Think about that. You're not allowed to cross the x-axis, so I can't use my x-intercept as one of my points. Okay, label it HA, and y equals 0. Then quickly we're going to talk about what the range is. All right, so what's our range? Bottom to top. Negative infinity, approaching 0, but non-inclusive. Hop over it, union, and then from there on, we're going up to infinity, only denying 0. Critical information. All right. So now I'm switching to my next color, turquoise here, and I'm going to look for my x-intercept, except I've already mentioned that. So look before you plug in. Can I graph an x-intercept? I'm denied crossing the x-axis, so there is none. So I can't use it, which is a pain because I like to use it. I'd like to be able to graph it. Tomorrow we'll have one. Let's do our y-intercept. Remember how we did that? You plug in 0 for your x to find your y-intercept. So let's plug in a 0. So that's y equals a negative 3 over 0 minus 1, which is 3 over 1, or negative divided by negative. I'll do that. Negative 3 over negative 1, which is 3. Right? So our y-intercept is 0, 3. Hey, look at that. You guys made a really good prediction that this graph was going to hop up here because of the negative sign. So shall we reflect it? Do you remember how to do that? It has to come over here, right? So it has to go to the intersection right here. Here's your intersection. Count. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. So you should have a point at 2, negative 3. Okay. All right, so now we're going to pick some points. So we'll pick points that are really close to our asymptote. I'm actually going to make that go back a little bit more space there. So we're doing a -3 over x minus 1. So let's pick points that are really close to our asymptote that we are for x that we haven't already graphed. We've already graphed x is 0 and x is 2. So what do you want to plug in? A 3 or a -1? What do you want to do? A 3? All right, so let's do a 3 because it's pretty close, right, to your vertical asymptote. So -3 over 3 minus 1, which is -3 over 2, right? So let's change that to -1.5. Probably that'll be a little helpful, right, for graphing purposes. So we're going to graph 3 down 1.5, which you know I can reflect, right? But we'll go ahead and plug in its partner. Since 3 is 2 spaces away from your vertex, your axes here where your intersections are, your asymptotes are, -1 should be its reflection because it's 2 to the left. Let's plug it in anyway so we can trust it. -3 over -1 minus 1, which is -3 over -2, which is positive 1.5. So we're going to graph -1 up 1.5. We've got 2 really good points here. That's enough for us to graph a reasonable graph. So I have to graph in this quadrant of my asymptotes. So starting really close to the asymptote and curving up through your points, and then slowly getting closer to your vertical asymptote. So there's that. Guys, try not to make your graphs do things like this. I see this a lot. Don't do that. Okay, just get closer and closer to your asymptote. And once you're really close, just stop and put an arrow. Okay. And then, of course, we're going to come down here where these points live in this sectioned off section of the graph. And we're going to start really close to our asymptote, curve, and then approach. And it's reasonable. It's not even close to perfect, but it's reasonable, especially since I know that these points that I have are accurate and my asymptotes are accurate. Okay, switching to my black pen, or I'm on my black pen, sorry. All right, so let's look at what this graph is doing. Read it left to right. What's it doing? It's increasing, right? All the time it's getting up, 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 and then way, way up to infinity. What about on this side? What's it always doing left to right? It's always increasing, right? So it's intervals of increase only, right? No decrease. Read it left to right. From negative infinity approaching +1, left to right, domain-wise. In union with, on this side of 1, what's it always doing? Increasing, right? It's always increasing. Always, always going up. I mean, barely up right here, but still up. Okay, and behaviors, quickly. So on this end, over here, this end, as x approaches negative infinity, as I move to the left, what's my y approaching? I'm getting closer and closer and closer to 0. On this end over here, actually down here, right? As x goes to positive infinity, your y approaches as well on the other side of 0. It gets close to 0 from the negative. Okay. All right. Last one. Today we're going to have some time to do some work. I'm so excited. All right. So here we go. Starting with our pink pen. Guess what we have to do? Factor. Yeah, we have to factor that denominator. So we're going to rewrite it as y is equal to 3 over, and let's factor that denominator. Difference of squares. X plus 2, x minus 2. We've been factoring, it feels like our whole lives by now, huh? It's a really important skill to have. If anything in algebra, you have to have that skill down. All right, so it's factored. Can I simplify it? No. So since I can't simplify, I'm going to write myself a note just to prep my brain for later. There are no holes. Since I can't simplify, there are no holes in my graph. There's asymptotes, but my graph doesn't have a hole. Okay, so, but we use that to help us. I'm switching colors to find our domain restrictions, right? Because my denominator can't equal 0, x plus 2 cannot equal 0, and x minus 2, that's not a minus sign, minus 2 cannot equal 0. Because that creates an illegal graph or an illegal fraction. So x is not allowed to equal positive or negative 2. Do you agree? So how many vertical asymptotes do I have? Yep, vertical asymptotes. X equals 2 and x equals negative 2. I have to deny both of those. So I'm going to come over here to x equals negative 2, and I'm going to draw vertical asymptotes. I'm going to deny my graph from touching those points. Same thing on this side. Again, why do I do dash lines? Because they're not part of the function. I'm not allowed to graph there. So I'm telling my people that are reading it, that's not part of my graph. And label them. X equals negative 2 and x equals positive 2. And so those are my vertical asymptotes. Let's do our domain. So reading this left to right, I can have any x from negative infinity all the way to negative 2, but not negative 2, in union with, so that takes care of this section. Now I'm in this section, right? Non-inclusive negative 2 to 2. I can graph in there. And then here, my x's can be from 2 to infinity. All non-inclusive because we can't graph the negative 2's and 2's for x. Denied. Okay, switching to a red pen. I love to hear the switch. Okay, so we look first. How do we do this again? What are we looking for to find our horizontal asymptote? The degrees. Okay, so let's look at the degree of my numerator. 0. Look at the degree of your denominator. It's 2. How do I know it's 2? Because the domain restriction had 2 deniers. So if I were to write a statement with those, I would say 0 is greater than, less than, or equal to 2. Less than. So since it's a less than statement, we know, therefore, that our horizontal asymptote is y equals 0 per our instructions. So we deny it. Y is not allowed to equal 0. So that means I cannot graph on the x-axis. Let's do our range. Reading this graph from bottom to top. Can I graph negative infinity? Yes. And as I rise, I reach or approach 0. But I cannot include it. I have to hop over it with a union. And then I can leave after 0. Then I can have any y after that. I just will never get y equals 0. It's not possible. Switching here to your critical points, your x and y intercepts. Can I have an x-intercept look at it? No. Okay, so there is none. The restriction denies it. Denies. Your horizontal asymptote denies. Okay. How about your y-intercept? Is my y-axis denied? No. Then that means I have a y-intercept. How do I do that again? What do I plug in? 0 for x. So I'm going to do 3 over 0 squared minus 4. You know, when I do these a lot of times, I'll just take my pencil and I'll cover up the x. And I can see the answer. It's negative 3/4. I'll just make all of the x's zeros in my head. Typically, that's what I'll do. Just because it's a little bit faster. So y is equal to negative 3/4. So our y-intercept is 0, negative 3/4. So let's graph that. 0, negative 3/4. Okay, so that's a weird section of my graph, right? Because, so now I know I'm going to graph down here in this area right here, but I cannot cross these asymptotes. So I'm actually going to graph what's called a parabola, dead center. And I know it's going to be a parabola of some sort because this 0, your y-intercept, is the midpoint between your asymptotes. Thank you.
Thank you.
Okay, but we'll get there in a sec. Let's pick some points now. So we have our x's and our 3 over x squared minus 4 and our y's. I'm going to redo that. That doesn't look good. Oops. Back. X. All right, so start picking some x's that are close to your asymptotes. I already have a point between my asymptotes. So let's pick an x that's to the left. Negative what? Negative 3? Yeah, that'll work. Negative 3. All right, so let's plug in a negative 3. So that's 3 over a quantity negative 3 squared minus 4. So we just have to do that negative 3 squared, which is 9, right? And 9 minus 4 is 5, so it's 3/5. So negative 3 and up 3/5. It's about right there. Okay, so now we have a point up here, and my graph has to switch over the horizontal axis, or the horizontal asymptote. So I'm going to graph here, then I'm going to jump to the other side of the asymptotes, and I'm going to graph here, and then I have to jump over the horizontal asymptote. So my point should be also up here. And this is feeling like a really even function. See, it's even because my only exponent is 2, and then my other exponents are zeros. And so I know that this is a reflection across the y-axis. Whatever I graph on this side, I can reflect to that side. It's got some symmetry. But let's plug in a 3 anyway, which would be on this side, so that you can see that symmetry. So if I do 3 over 3 squared minus 4, don't I also get 9 minus 4 in your denominator? Right? So that's also 3 over 5. So 3 and up 3/5. So I'm seeing that even symmetry here, which means everything is symmetric. So now we're going to graph. So I'm going to graph up here because I have a point here, and I have to approach the asymptotes, right? So I'm going to cruise that way, curve, cruise that way. Do the same thing on this side. Approaching asymptotes. There. Now I just have to do the center point, or the center graph. Because this is a midpoint, right? 0. Midpoint between my zeros here, negative 2 and 2. That'll be my peak. That'll be as high as this graph goes. So I'm approaching this asymptote and then curving up through that one, and that's as high as it'll go. And then approach this asymptote. So you kind of get a little parabola going there. Typically it'll happen if you have a quadratic in your denominator. If you have quadratics in both your numerator and denominator, sometimes you'll have 2 parabolas. Okay, so there's your graph. So now let's look at it as levels of increase and decrease. So as I'm reading this, as I come left to right, what's my graph? What's this line always doing? Increasing. All right, now I'm going to look at this one. What's it doing? Left to right. It's increasing until I get to here. And then it turns and it starts decreasing. So now it's falling. Now I'm going to read this side. As I go left to right, what's this graph doing? It's decreasing. So it has intervals of increase and intervals of decrease. And I don't think I'm going to have enough room down here to write that, but you can do this. So I'll write it really small. So intervals of increase starting left to right. Remember, you read these left to right. From negative infinity approaching negative 2. Hopping over that. And then it's still increasing, right? All the way to where? Negative infinity to 0. And then the graph stops increasing. It starts falling. So it has intervals of decrease, which go from, when does it start decreasing? When x equals 0. Nope. And then it decreases all the way to negative infinity here at which point? 2. And then I have to hop over 2 because I'm not allowed to graph that. And then I look at my graph. On this side of 2, what's my graph always doing? So from 2 to infinity, it's always decreasing. I'll do my end behaviors up here. So on this end, as x approaches negative infinity, as I go left, what's my y doing? What's it trying to reach? No. Look at my y. Y. It's approaching 0. I'm trying to get close to 0. Okay? As x, oh, and over here I'll go. As x approaches positive infinity, as my graph moves left, what's my y approaching? It's approaching 0 as well. It's getting closer and closer and closer to 0 as I go right. Confusing because of the x and y axis. You want to flip them, right? Okay, so there you have it. Your assignment, you have 8 problems to practice. I'm going to go ahead and hit pause here.